Hey guys, welcome to our second video on gas laws. In this video, we will be talking about Charles' Law. So Charles' Law, right, named after the French physicist Jacques Charles, who studied the effective temperature and volume of a gas in 1787. From all of his work, we get this equation, V1 over T1 equals V2 over T2. Okay, and we see that volume and temperature here are directly proportional. So what that means for us is that if one of these variables goes up, the other one must also go up. So if volume goes up, temperature has to go up as well. Okay, so when we use Charles' Law, let's look at how to solve. Okay, first thing I want you to remember is that pressure and amount are still affecting our gas that we're talking about. But in these problems, they're going to remain constant. So the pressure doesn't change and the amount doesn't change as we do these problems. Okay, so we're going to list our variables in the equation just like we did with Boyle's law. Fill in the numbers from the problem, plug them into our equation. We should only have one missing variable. Just a reminder there, if you have two missing ones, you need to get something from the problem still. If you have all of them, then one of them isn't right because we need just one to solve for. Okay, and then solve. That probably is the trickiest part with all the algebra here. At the end, check your units. Make sure that what you solve for is the same unit as the thing that was missing. And at the end, I'm going to add a new thing here. We want to check that it was directly proportional. We want to see that both went up or both went down. All right, so let's hop into an example here. Okay, so in this first example, a car tire holds 40 liters of air at a temperature of 280 degrees Kelvin. No air is released, but the volume drops to 37.5 liters. What is the new temperature of the air in our tire? All right, step one, list out all our variables. So we have V1, T1, V2, T2. From our problem, we have a car tire, that's our initial situation, that has 40 liters. So that's our volume one. And that 40 liters is at a temperature of 280 Kelvin. 280 K. V2, okay, after we have a change here, we're gonna see that the volume drops to 37.5 liters. And we're looking for the new temperature, so that is our missing variable. We don't know what the temperature is, but we do know it's going to be in Kelvin. Okay, before we get started, we can look here. We know that volume lowered here, right? If volume went down, then temperature also should go down. So our temperature at the end should be less than 280 Kelvin when we're done all of this. Okay, so next, after we have our variables, we plug all of these into the equation here. So V1 is 40 liters, T1 is 280 Kelvin, that is equal to V2 up top is 37.5 liters, and we do not know our T2. Okay, a little bit different from Boyle's law here because we're going to have to cross multiply. Right. So when we cross multiply, the top of the left side gets multiplied by the bottom of the right. The top of the right gets multiplied by the bottom of the left. Make sure you pull your units through all of this. So we get 40 liters times T2 equals 37.5 liters times 280 Kelvin. Okay, that is going to give us, we're going to divide 40 liters over. These two will cross out, and we'll get 40 liters on this side. Okay, when we do all the math right here, we end up getting 262.5 Kelvin. Notice liters cancels out, our only unit is K. 37.5 times 280 divided by 40 gives us 262.5. All right, so that is our number up here, 262.5 Kelvin. It has the right unit, it's K, that goes with T2, and it also went down from T1, right? 280 went down to 262.5, so it follows our directly proportional pattern. So that's our answer. In our next example, we're going to have V2 that's missing. So you guys can see how we do it when we're missing our variable up top. Same thing, okay? Well, in this example, we have a balloon. It has 9.2 liters of air at a temperature of 295 Kelvin. In this example, you put the balloon in the freezer and its temperature drops to 280 Kelvin. What is its new volume? How do we find that? Same steps as before. List your variables out. Our initial volume for the balloon is 9.2 liters. And our initial temperature before it's in the freezer is 295 Kelvin. Now the change takes place, the balloon goes into the freezer, its temperature drops to 280 Kelvin. So again, we have our temperature, it goes down from its initial, so our volume should also go down because these are directly proportional. We don't know what the volume is, so question mark there, but we do know it's going to be in liters. Okay. Now we take what we know and we plug it into our equation. V1 is 9.2 liters divided by T1, 295 Kelvin. That is equal to, we don't know what V2 is yet, so we just put our variable in there, and our T2 is 280 Kelvin. Same as last time, we're going to cross multiply first. So 9.2 liters times 280 Kelvin on the left, and on the right we get V2 times 295 Kelvin. Okay, when we multiply these two, we get 2,576 liters times Kelvin up top. Okay. Next step, we want to get V2 by itself, so we divide by 295 Kelvin on both sides. Okay, this cancels out. We have V2 by itself. And over here, we have Kelvin cancel out, only have liters as our unit. When we plug that into the calculator, we get 8.73 liters. Okay, so when we divide Kelvin by Kelvin, it cancels out. We only have liters left. This is our missing volume. All right, we just want to check up here too. 8.73 liters has the same unit. And our number went down from 9.2, so it follows our directly proportional setup here. All right, guys. So those are two examples there. That is Charles' Law. If you have any questions, send me some emails.